If you're in sales ops, you know this feeling deep in your bones. You open up your CRM, ready to get to work, and it's just a mess. A sea of duplicate records. It is so frustrating, right? It's chaos, and it's actively sabotaging your team's hard work every single day. Well, today, we're going to tame that chaos. Yeah, does this slide look a little too familiar? I bet it does. Look, this isn't some hypothetical classroom example. This is the messy reality in pretty much every large CRM out there. It's that daily headache that leads to crosswires, confused sales reps, and a data nightmare that someone, and let's be honest, it's probably you, has to clean up. So why can't we just, find the duplicates? Well, take a good long look at this number, 500 trillion. That is the number of pairs you would have to compare one by one to find every possible duplicate in a CRM with just a million records. Brute forcing this isn't just slow, it's computationally impossible. This isn't just a data hygiene task. It's a massive scale computer science problem hiding in your CRM. And the cost of just ignoring it? It's huge. We're talking sales reps stepping on each other's toes over territory conflicts. We're talking forecasts that are built on a foundation of bad data, money literally thrown away on marketing and data enrichment. It hits the bottom line for sure, but it also makes your job so much harder. Okay, so the problem is massive and the costs are very, very real. How do we even begin to fix it? Well, the answer isn't some magic button you can just press. It's a disciplined, systematic framework. It's about taking this seemingly impossible problem and breaking it down into small, manageable pieces. And this is our framework. This is our roadmap right here. A 3-stage pipeline. First, we're going to block, which is how we tame that insane 500 trillion number. Then we'll match using some really smart algorithms to score how similar records are. And finally, we decide. That's where we make the automated call. Merge it, reject it, or flag it for a human to look at. All right, let's dive into stage 1 blocking. Honestly, the best analogy here is doing your laundry, right? Before you can wash everything, you separate it into piles. Whites, darks, colors. You do this so you don't have to think about every single piece of clothing at once. Blocking does the exact same thing for your data. So here's the crucial insight. Instead of comparing every single record to every other record in the entire database, we create smart little groups or blocks. For example, maybe we put all the companies that start with the letters A, C, M, E into one block. Then we only have to compare the records inside that block. This one step right here eliminates the vast, vast majority of pointless comparisons. Now, there are a couple of ways to do this. On one hand, you've got standard blocking. It's simple. Use one rule like the first 4 letters of the company name. Super fast. The downside, you might miss some duplicates. On the other hand, you have multi-pass blocking. This gives you multiple shots at grouping duplicates together using different rules like company name, then maybe website domain, then phone number. It's a bit more work, but it catches way more stuff. So how do you know if your blocking strategy is any good? Well, it's a balancing act. You're looking at 2 key numbers. First is the reduction ratio. You want this to be super high, like over 99%. That means you've successfully eliminated almost all the junk comparisons. But at the same time, you need high pair completeness. This makes sure that in the process of throwing out the junk, you didn't accidentally throw out the actual duplicates you're looking for. Okay, we've successfully shrunk the problem from impossible down to just very hard. That's progress. Now that we have our potential pairs, we need a smart way to figure out how similar they really are. This is where we move beyond just looking for perfect, exact matches. But wait, before you can compare anything, you have to clean it up. This step, normalization, is absolutely non-negotiable. Just look at this slide. You and I know those are the same phone number, but to a computer, those raw text strings are completely different. Normalization strips away all the junk, the parentheses, the spaces, the plus signs, so you can compare the actual signal. This is the definition of avoiding garbage in, garbage out. Now, there's no single best algorithm for this. A really robust system uses a whole toolkit. You've got things like Winkler, which is awesome for catching simple typos. You have phonetic algorithms for names that sound alike but are spelled differently. And then you have more advanced methods that can understand that Acme International and International Acme are probably the same company, even though the words are flipped. So you don't just rely on one of these scores. You act like a detective and gather all the evidence. How similar is the name? Do the domains match? Do the phone numbers match? You put all of these scores together into something called a feature vector. Think of it as a complete evidence profile that tells you just how similar two records really are across the board. So let's recap where we are. We've got our manageable groups of records, and for each potential pair inside those groups, we have this detailed evidence profile, our feature vector. Now for the moment of truth. Stage 3, making the final call. How does a system look at all that evidence and decide if it's strong enough to declare a match? You've got two main roads you can go down here. On the left is the classic Felige Center model. It's basically a point system. It gives a certain weight to each piece of evidence. A perfect match on a website domain gets a lot of points. A fuzzy match on a company name gets fewer. It's easy to understand, and critically, you don't need a bunch of pre-labeled training data to get started. On the right, you have modern machine learning. If you do have thousands of labeled examples, ML models can learn really complex patterns and usually get you higher accuracy. The trade-off is simple, data versus power. And the output here is beautiful because it's not just a simple yes or no. A smart system automates the obvious calls. If the similarity score is sky high, you auto-merge. If it's super low, you just auto-reject it. But that tricky middle ground, the maybes, that's what you intelligently send over to a human data steward for final review. You let the machine do the heavy lifting and save the tough calls for people. Okay, the model is designed, the theory sounds great, but theory is one thing. Putting this into practice in a live environment is a whole other ballgame. Now, for the part that can be a little scary. How do we actually implement this in our production CRM without, causing a complete catastrophe? You have to handle this part with extreme care because a merge, especially in Salesforce, is a one-way street. You really can't undo it easily. That means you only auto-merge the matches you are supremely confident in. You have to be smart about picking which record becomes the master to keep the best data. You have to plan for things like API limits so you don't slow down the whole company. And for the love of all that is holy, test everything in a sandbox first. A mass merge could accidentally trigger thousands of unwanted emails or sales alerts if you're not careful. And all of that brings us to what might be the single most important takeaway from this whole thing. This is not a set it and forget it spring cleaning project. Duplicates will always find a way back into your system. Building a real, lasting solution means creating an ongoing capability for your team. A process of monitoring, review, and governance to keep your CRM healthy for the long run. So after all this, the question you really need to ask yourself and your team is this. Is your CRM a trusted system of record, or has it slowly turned into a messy, unreliable system of records? Plural. Because taming that chaos is what truly transforms your data from being a liability into a genuine strategic asset.